Is the screen visible to you, right?
Yes, ma'am.
Yes, ma'am.
Fine, fine.
Yes, ma'am.
It's, we are talking about the languages. Here, the language L is equal to nothing I have given in the set. So, it is called an empty language. Not even an epsilon is there. So, it is an empty language, no string at all. Even if it is an empty string, null string, that is called your epsilon, we cannot say that L is different from 5 because it is not empty. You can perform few operations on the languages. Suppose A is the language, B is the language, you can perform union of it, intersection, difference, and then complement. Complement, you know that from the universal set, you just uh, get the difference of your set. Remaining items which is not in your set will exist. So your next thing is these are all few operations over the languages. So here, if I consider my language 1, what is my language 1 in the screen that you are seeing is strings with an even number of A's, right? Strings with an even number of A's. So only even number of A's are possible. You could see that in language L1. So what type of language even number of A's means even 0 number of A's is also a language. 2 number of A's, 4, and then 6 like that. Multiples of 2. Even 0 is also. That time epsilon will come to matter. You could see that. And coming to L2, what a type of language it is? Language has to be enclosed within curly braces. Make sure strings with no B's, right? Strings with no B's means only A's, but the count of A's, the number of A's don't have any constraint. It could be odd number of A's or even number of A's, right? Have you understood the language 1 and language 2? So the language 1 is only even number of A's. There won't be any B's. Language 2 is what? With an even number of A's. Sorry, language 1 is even number of A's. There is no constraint on B's. Language 2 is strings with no B's. Means B should not be there. Number of A's can be any count. Could be even or odd, anything. So when I union it, if I want to get a union operation over L1 and L2, what type of language you will get? So strings of A's and B's, right? Both are there. In language L1 you have A's, in L2 you have no B's, but in L1 you have B's also. All strings of just A's plus strings that contain B's. Because in L1 we are not telling about no B. So only we had a restriction over even number, even length of A's. If it is A present, A length should be even. Correct? But in L1 you can include B's also. But in L2 you could not include B's and no constraint over the length of A's. Now what is my final statement when I'm performing union operation on both? All strings of just A's plus strings that contains B's and even number of A's. And even number of means string of A's and B's, but the length of A's is what? All strings of just A's plus, okay, because your L2 is all strings of just A's, only A's, and L1 is strings that contain B's and even number of A's. That is your L1, right? If you have any doubt here, you can raise here. Here, when I am performing union operation, the first thing is all strings of just A's are your L2. Just A's, no B's. That contain B's and even number of A's is your L1. Shall I move?
Yes, ma'am.
Okay, when I perform intersection, what do you know that? It's a common factor in both, right? When I'm performing intersection between both, what is the common factor that you might have seen?
Only even number of A's.
Only A's, right? Even number of A's. Because in L1 also you have A's, in L2 also you have A's. In L2 you have even number of A's as well odd number of A's, but in L1 you have only even number of A's. In L2 you don't have B's, so I cannot consider that in L1. So what you can consider now is only even number of A's is the common factor in both L1 and L2. So that is their intersection. Fine. Now, so what is sigma actually? Sigma is nothing but set of all input alphabets or input symbols. Here for my language, the input symbols are 0 and 1. Wait. Input symbol is 0 and 1. So what is sigma square is, see here on top of sigma I didn't see anything because by default its power is 1. So it will give you one lengthed alphabets. One lengthed alphabets or one lengthed strings. Right, one lengthed things are 0 and 1. When it is sigma square, it is nothing but two lengthed things on the alphabet what is given to me. I have only provision of the alphabets which are 0 and 1. So I can make two lengthed strings over that alphabet 0 and 1. So the two lengthed things are 0, 0, 0, 1, 1, 0 and then 1, 1. You might have studied in logic design. Okay. Then what is summation star? Summation star is set of all languages that is going to be developed out of it from 0 or more number of possible strings. So star itself, sigma power star, it indicates the length of any, it means 0 or more. When the length is 0, you tell me, any one of you tell me, when the length is 0, what is the string to be accepted?
Epsilon.
Very good. The length is 0, the string to be accepted is what? Epsilon. When the length is 1, nothing but 0 and then 0 or 1, anything. When length is 2, 0, 0 or 0, 1, 1, 0, 1, 1, then it continues. So sigma star is any of the language. It's a union of all the length of alphabets. Then coming to concatenation operation over the language. So if I consider two languages, L1 and L2, here there is a string S, there exists a string S that belongs to L1, and there exists T that belongs to L2. So finally, what is my string when I concatenate? ST, right? So what do you mean by W? W is a string actually. W is a string. We represent W for the string. It's a that belongs to sigma star, means you have 0 or more number of characters or alphabets or symbols in your string. The meaning of this is, after I concatenate, I get a string. If you concatenate two languages, you will get two strings or sorry, if you concatenate two things, right, two languages, so even the language, how you got the languages? By combining the strings only, na? There exists a string W that belongs to what? Sigma star. Now sigma star is what? It's a language actually. So you will get a string when you concatenate two things. And in that, S is a string that belongs to L1 and T is a string that belongs to L2. Finally, the resultant after I combine is ST. So don't need to much worry about all these representations, only to make you familiar with it. That's all. Okay, this screenshot, this page, it's very simple. I'll anyhow share the notes. Later you can check it out. Just an operations, that's all. If L1 is AB and BBA, L2 is this. If I concatenate, what and all the things I'll get? AB, AA, AB, B, AB and then BA. Take one string in a language, concatenate with the entire strings of the L2. Take the next string of L1, concatenate with all the strings of L2. That is the thing. This is where you have to pay an attention. Here we have an alpha. A is a set of alphabets. Sometimes they may say A, sometimes they may say sigma. Both are same. Finally, we call it as a set of all alphabet or set of all input symbols. So already we have seen what is sigma star, clean closure. Here it comes minimum string is what in sigma star? The epsilon, the length 0 is also a possibility. But when you come to keen plus, sigma plus or a plus, we call it as clean plus. You cannot see that epsilon here because we don't allow an empty strings when it is a clean plus. Minimum one length, at least one alphabet or at least one character should be there. One input symbol should be there in clean plus. This is the major difference between these two. Star, power star means, clean star means 0 or more number of characters. Clean plus means 1 or more number of characters in a string. Is it clear?
Yes, ma'am.
Ma'am.
When your a star equal to a plus, if and only if epsilon is a part of your string. So you will consider that also to a plus, right? Then epsilon also will become as a one lengthed string. Only when epsilon is an input alphabet. Suppose I have a is equal to within the curly braces epsilon comma 0 comma 1. These are all my set of input alphabets. That time your a star is equal to a plus. Because I have that in my string, right? Epsilon is there in my string. Is one of the input alphabet. So it will come to plus as well. When it is not there, I cannot say that a plus and a star both are same. Okay, so till now what we have seen is only the preliminaries or the basics or the terminologies what you have to be familiar with. The next one comes exactly your concept called finite state motion. Any motion you take in the real-time example also, it will be in one state, right? After consuming some input, you take any electric machines, right? Any vending machines. So you provide the coin. So it will take some input and it will give you something, right? Output. So it's all about state transitions from one state to the intermediate state or to the final state. So at last, your output has to be either accept or reject. Whether you have to end up with an acceptance state or reject state. Either you may lose or win. So a finite state machine is a computational device whose input is a string and whose output is one of the values that we can either accept or reject. Here the string is nothing but your input string. Input string can be of any form. It could be a set of all input alphabets, set of all numbers, or set of all special symbols, anything. So you provide some input through the means of strings and you get the output whether it has to be accepted. The string is going to be accepted by the machine. That's what I told you in the previous class. We are going to check whether the machine is going to accept our language or not or reject. So here you consider this is our machine, finite state machine. So if I provide my string, I can check whether that string is going to be accepted or not. It's my duty to develop a machine in such a way that I have to see that whether the string is going to be accepted or not. Clear? So we call such machines as finite state machines. Sometimes we call it as finite state automata or just finite automata. All these things comes into picture. The same name. Finite state machines, finite state automata or finite automata, FSM, FSA or FA, all are same. Okay. Suppose I simply call this finite state machine as M. What is that? M. An input string is fed to M, one character at a time, left to right. See, for a machine to read an input, there is a strategy. It always has to read the input. Suppose I am going to give the input in the form of alphabets. A, B, B, A is my input. What is my first character? A. It starts reading the input from left to right. At the end of that string, when I reach my string end, whether I have to be either in accept state or reject state. One character at a time. In between, I may go so many transitions from one state to other state. So I am mission M. I'm going to read alphabet A. I may change my state from my existing state. I may go to the state 0 to state 1. Then what is my next input alphabet? B, right? I'll read that. I'll go to state 3, state 4 like that till the final state. Make sure when your input has ended, you must be either accept state or reject state. If you are in accept state, the machine is going to accept your language. Reject means it's not a final state. Clear?
Yes, ma'am.
Okay. So for any thing you take, there are two types like finite state machines. If you consider, you have deterministic finite state machine and non-deterministic finite state machine. So the difference is very, very, I mean, even for me to teach you, the differences are very, very really good and you will enjoy in like, so when we say deterministic, when we say non-deterministic, and if I provide you NFSM, NDFSM or NFSM, anything, so you need to convert that into deterministic one. So deterministic means, I think now I cannot tell you. So like with the pictorial representation, we can, it will be better. I told you that the machine is going to change its state after consuming an input, right? And first of all, I should be very, very familiar with what and all my input characters are. Looking at that pictorial representation, tell me what is your sigma?
A and B.
Very good. So your small a, small b, right? That is there. So inputs. For example, so any machine you had a start state and end state, right? Start state means initial state, end state means final state. The initial state is represented with an right arrow. Like here in this figure, the initial state is Q0. The accepting state or the final state is called Q4 because it is represented with a double circle. Represented with a double circle. See, my set of all input alphabets where sigma is equal to within the curly brace, I can write that a comma b, small a comma b, small a comma b. You could see that here from every state there is a transition out of every input symbol. What is your input symbols? There is a transition over a from Q0. There is a transition over b from Q0. And consider Q1, you had transition over A as well over B. From Q2, you have transition over A as well, transition over B. Like that, every state could be a self state also. Q5 is a self state. But there should exist a transition from each and every input symbol, but exactly once. But exactly once. See, from Q0, do I take a transition out of A 2 times? No, right? I have taken transition out of Q0 by A only once. That is called determinism. From a state, you can have a transition to one more state. On each and every input symbol, you should have a transition from a state on each and every input symbol only once. Only exactly once. So that is your deterministic finite state machine. Final states can be anything. It is not necessary that you should have only one final state. You can have n number of final state, but start state has to be only one. I'll discuss that further in a depth in the next class. I think you have by 2 o'clock, right? Do you have a class by 2 o'clock?
2:30, ma'am.
2:30. Okay.
2:30, ma'am.
Okay. I think this is a lunchtime. Uh, I'll just explain you. I think tomorrow first hour I have some timetable clashes are there. So I'll schedule that according to. So if any one of your classmates didn't receive the email from my side, please. Yesterday I asked for the one who didn't receive, but everybody are messaging. Only those fellows, please reply. I'll just end up the class here. Any doubts for today's class? We'll still in depth. I'll just explain what is NDFSM, what is DFSM. I have a lot of exercises to be given to you. You have to construct and show me by switching on your videos. Fine. The further classes. Because this is not the subject that I can, hereafter I cannot, I'll be simply talking and you will be listening. From your side, I need the answers. Is that fine?
Yes,
Yes,
ma'am.
ma'am.
Yes,
Good.
ma'am.
What to say? I'll just end up here. I'll just take an attendance sheet from your side. Be in the line.